Okay, so today we're going to be going over 2.4, and it's more just logarithmic stuff. So today you're going to be able to use log properties to find equivalent algebraic expressions, okay? When it talks about the log properties, that was on this page right here, right? So I'm actually going to take a snip of this because I'm going to use this over and over again as soon as I find my snip. I'm going to take this and I'm going to snip it onto like here probably, just so I can access it over and over again, okay? So it says that we're going to use log properties. Use log properties to find values for log expressions using other known values. So again, we're going to be using log properties. And then last but not least, how can the properties of logs help us in working with log expressions? So we're going to just be doing this thing over and over again. We're going to be using these. If you don't know these, that's okay. Just you gotta push yourself to think about them a little bit differently. Okay, so let's move on. So it says Abe and Mary are feeling good about their log rules and bragging about their mathematical prowess to all their friends when this exchange occurs. I know you guys do this, right? I know you guys brag about math. No? Okay. So Steven says, I guess you think you're pretty smart because you figured out some log rules, but I want to know what they're good for. Abe says, well, we've seen a lot of times when equivalent expressions are handy. Sometimes when you write an expression with a variable in it a different way, it means something different. Okay. So it says, what are some examples from your previous experience where equivalent expressions were useful? So this is just us talking. And so if you think about like graphing, there's equivalent expressions. Now, y equals mx plus b is my personal favorite of graphing, but sometimes they don't give it to me in that equation. So then I would change it so that it looks like y equals mx plus b. So that's my personal experience in terms of what expressions are used for. Certain ones are more useful for certain contexts, like, for example, graphing, like I just said. Okay, Mary says, I was thinking about the log logic task where we were trying to estimate and order certain log values. You guys remember that, where we were like, oh, it goes here, it goes in between these two, oh, log base 2 of 2 means this. I was wondering if we could use our log rules to take values we know and use them to find values we don't know. This is classic math right here. This is very classic math. So classic math says, I want to use something that I do know to find something I don't know. Okay. So for instance, let's say you want to calculate log base 2 of 6. Now think about log base 2 of 6. I don't know log base 2 of 6 because I don't know 2 to the what. Like this is asking me 2 to the what gives me 6. Now, I don't know about you. I don't know that off the top of my head. I know it's bigger than say 2 and it's smaller than 3, but I don't know exactly what it is, right? So then because you know what log base 2 and log base 2 of 2, if you know what log base 2 of 2 and log base 2 of 3 are, then you could use the product rule to say log base 2 of 2 times 3 is log base 2 of 2 plus log base 2 of 3, right? So then we say, okay, and then he says, that's great. Everyone knows what log base 2 of 2 is 1, right? But what's log base 2 of 3? Oh, I saw somewhere. I saw this somewhere. Log base 2 of 3 is 1.585. So Mary's idea really does work. And so if you don't know what log base 2 of 3 is, I don't expect you to know this. This is something that my calculator would tell me. But notice here, you can't just plug in log. So for your answer for our test, let's just say, you can't just plug in log base 2 of 6 into a calculator. At least, so I mean, some of you figured this out because you Googled it, but we haven't talked about log base 2 yet. Nothing, you're not supposed to put anything for these slides yet. Exactly. So here's them working it out. Notice they're using this property right here. Oops, wrong way. They're using this product rule property, which says if I multiply here, then I add out here. So they're multiplying here, so they add out here, right? And then they simplify, you know this, log base 2 of 2, log base 2 of 3, and then they simplify. Moving on. Based on what you know about logarithms, explain why 2.585 is a reasonable answer for log base 2 of 6. Okay. So I kind of explained it already, right? But let's go through this. So I know that, oh, you guys tell me, how do you know that 2.585 is a reasonable answer for log base 2 of 6? What do you know about log base 2? Because we know it's closer to 2 than 3. Good, kind of. But tell me why you know that. Oh, awesome. I gotta put this up. Sorry, give me a second. Let me find my little snippy tool. There it is. Okay, this is exactly what I was looking for. Thank you very much, sir. Copy. Hey, Ashley, can you turn off your camera, hun? Right here. Boom, right? So this is what one of your classmates says. He says, because we were trying to figure out 2 to the power of what equals 6, we know 2 squared is 4 and 2 cubed is 8. So the answer will fall somewhere between 2 and 3. So this kind of reasoning got this person a really high grade on the test, right? This kind of reasoning got this person a really high grade on the test. Because why, Miss Johnson? Because so he showed me exactly why he thought his answer fell between those two numbers. So if you're able to explain it like this, it'll make sense. So this is what goes on this one. And you guys all, most of you got really well on that quiz. Okay, Steven says, I've got one. I could figure out log base 2 of 5 like this. So log base 2 of 2 plus 3 equals log base 2 of 2 plus log base 2 of 3 is this. Can Stephen and Mary both be correct? Explain who's right and who's wrong, if anyone, and why. So I don't know if you guys got to this slide. Let me see. Oops, sorry. Let me see. Not yet. Okay. So can you take a second and go through, like, explain if Stephen is right, or if Mary is right, or if both of them are right, or if both of them are wrong. So I'll pause it right here. Okay, so someone says, I saw a couple of your answers already. And someone said, no, that doesn't make sense. So can you tell me, what would you explain to Stephen? What would you say to Stephen to help him understand that he's not correct? What would you explain to Stephen? What would you say to him? You all furiously typing in the chat right now. Scooch this over a little bit more. Ah, someone's got an answer in there. Awesome, awesome, awesome. Put your answer in there. Someone says Steven's wrong because in parentheses he adds 2 and 3, and for this to work, the 2 and the 3 in the parentheses have to be multiplied so we can break it up by adding. Very good. Very, very simple. So what this person does, again, classic person for responding. Again, this person also got a pretty strong grade on the test as well. So this person says all of this. This is just proof that Ms. Johnson doesn't talk to herself. This person just goes back to the rules. So I'm gonna always bring you back. I don't know why it's not letting me switch over. I'm always gonna bring you back to your rules or your definitions. So here, I'm just gonna move this down. You're not gonna move down. Oh, are you stuck? Whatever. Okay, so this person here is explaining this rule right here. So in order for that to happen, it needs to be a product. That's why it's called a product rule. So you can't get the then if the if isn't set up, right? So you say, hey mom, can I go to the movies with my friend? And she's like, sure, if you finish all your homework, right? And you're like, okay. So we see you at the movies. So you better have finished your homework if you're at the movies, right? You don't get the then if the if doesn't work. Does that make sense? You can't use this side if this isn't the correct, if it's not the same on this side, right? In order to use a rule, you have to follow the rule. That's why it's called a rule. Okay, so let's just move on. Where did that go? I wanted it here. Okay, so it says, now you can try, oh, let me go back to this guy. Okay, so now, wait, let's see. So no, they can't both be. And then it says, now you can try applying the log rules yourself. Use the values that are given and ones that you know, like log base 2 of 2 to explain the following. So here's this. So Abe and Mary are feeling good about their log rules and bragging. Oh, wait, this is a repeat. Sorry. Here you go. So the 3 rules are here. So notice the rules are here. And I'll tell you again and again, this needs to be on a Post-it somewhere. Post-it somewhere. It needs to be on a Post-it somewhere until it gets in your brain. So the way, just so you know how I used to study, for my notebook, whenever there was this kind of thing that I needed to know, I wrote this at the top of every single page of my notebook that I needed it for. And then I didn't have to memorize this rule come test day because I wrote it like, 5 or 6 or 7 times. So right now, what I want you to do is I want you to pause and I want you to try evaluating log base 2 of 9 based on, now it's kind of funny because it's up here. Log base 2 of 3 is up here, log base 2 of 5, and log base 2 of 7. I'll give you a hint, okay? The way you do this is you play a number game. You say, I want 9, okay? I want 9. So how can I either multiply, this rule is wrong. It's supposed to say divide. Maybe there is a division symbol, but I can't see it. And then this says to the K, right? So I'm going to try to get to 9 using the building blocks of log base 2 of 3, log base 2 of 5, and log base 2 of 7. Okay, so this is kind of like a recipe. Like I'm trying to make something, and these are the only ingredients you can use. Okay, so go ahead and pause and then try doing this one on your own.